Welcome to the sleepy atom, a place where science feels like a dream whispered through the stars. Tonight, we drift through the newest stories carried to us by light itself, from the distant jets of galaxies to a mysterious visitor named 3I Atlas. These are not just data points or telescope images. They are cosmic letters written across billions of years, waiting for someone calm enough to read them. The James Webb Space Telescope, or JWST, has begun to uncover the universe in ways we once thought impossible, and at the same time, far beyond the planets we know, an interstellar comet called 3I Atlas has arrived, glowing, whispering, carrying secrets from another sun. So, let's close our eyes, slow our breath, and listen to the stories of light, dust, and motion that connect everything. Because somewhere between the stillness of space and the warmth of our curiosity, you might just hear the universe speaking back. The galaxy M87 sits 55 million light-years away, but its heart burns bright with a supermassive black hole that shoots out a jet of energy longer than our entire galaxy. JWST recently turned its golden mirrors toward it, and what it saw changed how we imagine cosmic violence. Through infrared eyes, the jet isn't just a streak of light. It's a living river of particles twisting through invisible fields, glowing softly where matter and magnetism collide. Somewhere deep inside that storm sits silence, the kind that bends time. Imagine standing near that beam, watching atoms dance at nearly the speed of light. It's strange to think that something so fierce can also look so peaceful through JWST's gaze. Scientists once thought we knew how these jets worked, but Webb showed faint filaments spiraling within them. Details Hubble could never catch. It's like seeing an ocean wave in slow motion, realizing the surface hides thousands of smaller ripples. And there's something poetic about that even in the most chaotic places, order still finds a pattern, and beauty still hides in violence. Ahead in this video, we'll drift closer to the strange visitor crossing our solar system, 3I Atlas. When astronomers first spotted 3I Atlas, they expected a familiar icy glow, but instead it shimmered differently. Its light behaved in reverse, darker when the sun hit it straight, brighter when seen from the side. This rare phenomenon called negative polarization has never been seen in a comet before. It's like the universe reminding us that not everything obeys our rules. JWST's instruments found that 3I Atlas scatters light in a way that suggests ultrafine alien dust, perhaps older than our own solar birth. Each particle might have drifted through interstellar space for billions of years before arriving here. Imagine it, tiny grains carrying the memory of another star's explosion, now glowing faintly under our sun. The way 3I Atlas bends light could rewrite what we know about cosmic dust and early planetary chemistry. Some scientists quietly wonder if its strange glow could hint at materials never formed in our region of the galaxy. Maybe that's why 3I Atlas feels more like a messenger than a comet, a soft-spoken traveler with a story older than time itself. When JWST looked closer, it found something even stranger. 3I Atlas carries a coma rich in CO2, carbon dioxide, something few expected from an interstellar body. It means this comet once lived near a warm star where ice turned to vapor. Perhaps 3I Atlas was born in another solar system's habitable zone, then flung into the void long ago. The discovery adds a human warmth to this cosmic traveler. It has breathed before, in another sky, under another sun, and now it releases those same gases here, whispering across the void like the last breath of a forgotten world. Scientists are amazed because JWST's spectra show more than just CO2. Traces of organic molecules shimmer in its light, suggesting the building blocks of life can survive interstellar exile. So 3i Atlas isn't just a visitor, it's a survivor. Every molecule it carries could tell us how chemistry travels between stars, how life's ingredients never truly die, just move from one sun to another. Most comets are made of rock, ice, and carbon dust, but 3i Atlas is different. It's emitting iron and nickel vapors, metals forged in the hearts of dying stars. For scientists, that's like finding gold dust inside a snowflake. It shouldn't happen, not out here, not in deep space. JWST and ground telescopes detected these metals glowing faintly in its tail, meaning 3i Atlas was once close enough to a star to melt, then refreeze. A cosmic blacksmith's relic traveling through time. That tells us something profound. Even destruction leaves behind creation. 3i Atlas carries metals that might seed new planets someday, spreading the ingredients of worlds as it drifts onward. There's poetry in knowing that what we call debris could be the blueprint for new life elsewhere. And maybe that's the quiet message hidden in 3i Atlas's metallic glow. Endings are never final, only recycled into new beginnings. To compare 3i Atlas with any other comet is like comparing a dream to a memory. While typical comets loop around our sun in predictable orbits, this one moves on a hyperbolic path. It will never return. It's passing through once, on its way back to the deep unknown. Its speed, its glow, even its composition defy the models we've used for decades. In a sense, 3i Atlas has broken every cosmic rule and still moves gracefully through the void. Some astronomers call it the Wanderer of Worlds, believing it carries material from a completely different galaxy or star system. To watch it is to see the universe trading stories between suns. And maybe that's what makes 3i Atlas so hauntingly beautiful. It's not just visiting us. It's reminding us how small and connected we all are, drifting together in this vast sea of light. When the James Webb Space Telescope pointed its mirrors toward a patch of darkness smaller than a grain of sand held at arm's length, galaxies bloomed into view. Thousands of them. Some looked like tiny whirlpools, others like glowing embers floating in ink. The image wasn't just beautiful, it was unsettling. A reminder that what we thought was empty has always been full of light, too faint for our eyes. Each pixel was time itself. JWST sees in infrared, meaning every shimmer you see is billions of years old. Some galaxies are so distant their light began before Earth had oceans. To look at that image is to look backward, a silent film of cosmic childhood playing endlessly across the sky. Astronomers noticed something strange. The galaxies were larger and brighter than models predicted. It's as if the universe grew faster, formed stars quicker than we've been teaching for decades. That small discovery rippled through cosmology, gently forcing us to admit, maybe the universe still hides its early diary, written in colors we barely understand. And that's the quiet wonder of Webb. Each photograph becomes a mirror. We think we're staring at galaxies, but somehow we end up staring back at our own curiosity, realizing how little we truly know. Every comet shines by reflecting sunlight, but 3i Atlas does something different. Its light twists, dims and brightens like a living heartbeat. Even when scientists calculate its angles, the data dances out of rhythm, almost teasing them to look closer. Spectrographs show wavelengths that don't match any known mixture of dust or gas. Some wavelengths appear inverted, meaning the comet might scatter light backward like a mirror turning inside out. That shouldn't happen, not unless the dust grains are shaped in ways never seen before, maybe spongy, porous, or coated with alien ice. It's in moments like this that astronomy feels personal. You can almost picture scientists late at night staring at graphs that refuse to behave. Each curve is a mystery disguised as a line of light. One astronomer called it a comet from a different physics. Maybe he was half joking, but in his eyes there was wonder, not confusion. If 3i Atlas can reflect light in ways that defy our optics, what else might interstellar travel carry between stars? Perhaps these strange optical signatures are the universe's way of writing in poetry instead of numbers. Whenever something mysterious appears from deep space, imagination awakens. 3i Atlas has drawn whispers similar to its predecessor, Oumuamua, the first interstellar object that once made scientists wonder if it could be artificial. No one is claiming this comet is built by aliens, but its trajectory and metallic composition are so odd that even conservative researchers pause mid-sentence. If it were a probe, it would be a quiet one, no signal, no maneuvering, just drifting with purpose. That idea is less about truth and more about curiosity. How humans can't help but look for meaning in silence. And there's beauty in that instinct when we see something unknown and instinctively ask, who sent it? Maybe the answer is no one, or maybe it's the universe itself sending a reminder of how small we are. What makes this theory linger is how strangely 3i Atlas behaves. Its speed shifts slightly without visible jets of gas. Its spin changes inexplicably. Sometimes nature imitates technology so well that the two become indistinguishable. Even if 3i Atlas is only a natural wanderer, it carries a lesson deeper than any probe could. The moment we stop wondering what's out there, the sky goes quiet. The Hubble showed us the visible universe, but JWST lets us see the invisible. Its infrared vision cuts through cosmic dust, revealing what was always hidden behind the veil. It's like finally hearing a song we've been watching people dance to for decades without hearing the music until now. In one frame, Webb revealed stars being born inside pillars of gas we thought were empty. In another, it saw the glow of the first galaxies ever formed, faint, fragile dots from the universe's first few 100 million years. To realize those photons traveled for 13 billion years just to touch our mirrors is to feel a kind of holy awe that doesn't belong to religion but to curiosity itself. Webb's infrared filters even turn darkness into color, reds and golds that humans have never seen before. It transforms data into emotion, math into something that feels alive. And somehow, it reminds us that the universe has been performing its light show for billions of years, patiently waiting for someone to notice. So when people ask why JWST matters, the answer is simple. It's the first telescope that lets us see the universe not as a map, but as a memory. Right now, 3i Atlas is speeding through the solar system at over 130,000 miles per hour. Soon it will pass closest to the Sun, its ice turning to gas, its core cracking under light. From Earth, it will glow brighter, its tail stretching across space like a ghost trail that never truly fades. What happens then depends on its past. Some interstellar objects shatter when the Sun's heat touches them. Others survive and slingshot back into the void stronger than before. Either way, this moment, its meeting with our Sun, is like a handshake between two star systems that will never meet again. Scientists will watch for changes in its light, hoping to learn how materials from other suns behave under ours. In a way, the Sun becomes a teacher, and 3i Atlas its brief, brilliant student. Perhaps somewhere out there, another civilization is watching their own visitor from us, wondering what our dust is made of. As we open more chapters ahead, the story will shift from light and motion to something deeper. What these discoveries mean for our own place in this silent, living universe. Scientists recently announced something that sounds like fiction. A black hole star. It's neither a typical star nor a true black hole, but something between. Imagine a sun so massive that its own gravity traps light, yet somehow it still shines. A paradox wrapped in plasma. These theoretical giants might have existed before galaxies, glowing softly with radiation from matter falling inward. They bridge the moment between creation and collapse. Cosmic infants that never grew up or died, but lingered in that strange twilight in between. JWST may have caught their signatures, ancient glows with temperatures and colors no ordinary stars produce. If confirmed, it changes everything we thought we knew about early light, suggesting the first objects in the universe weren't stars like ours, but immense shadows pretending to be light. And maybe that's what makes this story haunting, that even in the beginning, darkness and radiance were already learning to dance together. The first JWST deep field image looked like a painting of forever. Thousands of galaxies, spiral, elliptical, distorted, all caught in one frame. Yet the longer you stared, the smaller you felt. Every color was a time machine. The redder the galaxy, the older its light. Some of those faint spots existed before the Milky Way was even born. But what amazed astronomers wasn't just the beauty, it was the structure. Galaxies were forming faster and earlier than theories predicted. It's like walking into a nursery and finding fully grown trees where seedlings should be. It means the universe built itself more efficiently, more mysteriously than we ever imagined. And maybe that's why these images are so magnetic. They make us realize that creation doesn't need time to be beautiful. Sometimes it just blooms when no one's watching, quietly weaving the cosmos together, one faint shimmer at a time. Every comet follows a pattern: ice, dust, sunlight, melt, tail. But 3i Atlas refuses to play by those rules. It moves faster, glows strangely, and breaks apart slower than models suggest. Its dust doesn't scatter like ours. It absorbs light in ways no one predicted. Some scientists think it carries compounds rare in our solar system, maybe long-lost ices or metals from a colder, older star. Others believe its path hints it was ejected by gravitational chaos, a planet torn from its orbit somewhere far away. Every theory feels like a half-remembered dream, beautiful but incomplete. Maybe that's why 3i Atlas fascinates us, because it's proof that even after centuries of studying the sky, the universe still keeps a few jokes up its sleeve. It's a wanderer that breaks every law yet follows its own. And somehow that feels strangely human too. For decades, we've known M87 had a massive jet blasting out of its black hole, a stream of energy so bright it can outshine galaxies. But Webb has now revealed something we'd never seen before, a counterjet, moving the opposite way. It's like finding a heartbeat where we thought there was only pulse. This counterjet suggests the black hole spins faster than models predicted, twisting magnetic fields like ribbons of firelight. It helps explain how these cosmic engines power galaxies, and why some regions of the universe seem alive with invisible motion. To think, all this movement, all this violence, happening inside what we once called emptiness. And perhaps that's what the universe has always been teaching us. There's no true stillness out there, only the slow breathing of energy we've just begun to see. When light hits an object, it usually scatters in predictable ways, brighter when seen directly, dimmer at angles. But 3i Atlas does the opposite. It gets darker when sunlight hits it face on, and brighter when viewed sideways. Astronomers call this negative polarization, and it's as strange as it sounds. It could mean its surface dust is made of ultrafine porous grains, almost like cosmic sponge material, reflecting light in alien geometries. Or perhaps its particles align magnetically, creating patterns that bend light differently than anything we've seen before. Whatever the reason, it proves one thing: not all light behaves the same way everywhere. In other star systems, physics might wear different clothes. And that's what makes 3i Atlas magical. It reminds us that light, even after traveling for billions of years, can still surprise the eyes waiting for it. As we open more chapters ahead, we'll drift deeper into what these discoveries mean for us, not just as scientists, but as dreamers tracing the soft footprints of stars across the dark. Light travels slowly enough to tell stories, and JWST has found the oldest story yet. Hidden in a patch of space that once looked empty, Webb detected faint red glows from galaxies formed less than 300 million years after the Big Bang. That light began its journey before our Sun, before the Milky Way, before even meant anything. Each photon is a survivor of time itself. It wandered through dust, gas, and gravity wells to reach us, carrying whispers of when matter first learned to shine. Seeing it feels like hearing the universe's first heartbeat, soft but steady, echoing across eternity. Astronomers call this cosmic dawn. And when Webb caught that glow, it didn't just photograph light, it photographed memory. Some galaxies appeared surprisingly mature, their stars already heavy with elements, as though creation skipped childhood entirely. It's humbling that the light we see tonight left its home before our world even existed. In that silence, you almost sense the cosmos looking back, grateful that someone finally noticed its ancient glow. Every new observation of 3i Atlas rewrites a page of science. First it broke the rules of light, then of chemistry, and now of structure, fragments that refuse to move the way comets should. It's as though the universe built this traveler out of contradictions, just to see if we were paying attention. Some parts of its tail curve inward instead of outward, a pattern no comet in our system has ever displayed. And its gases react strangely with sunlight, producing colors that shift from turquoise to bronze within days. The more scientists learn, the stranger it gets, like chasing a shadow that changes shape each time you blink. No model fits perfectly, and that's what keeps researchers awake at night, sketching possibilities that sound like science fiction. Maybe 3i Atlas carries the chemistry of forgotten stars, or maybe it's simply reminding us that space still loves to surprise. Either way, it's proof that even in the most measured science, there's room for wonder that refuses to be tamed. When sunlight hits ordinary comets, the color remains steady, pale, icy white. But 3i Atlas plays by different rules. As it nears the sun, its color deepens, from silver to emerald, then gold. At first, astronomers thought it was camera error, until multiple observatories confirmed the same shimmering shift. It turns out the comet's gases might contain unusual metals that fluoresce under certain solar wavelengths. In simpler words, it glows differently depending on the sun's mood, a living prism drifting between worlds. This strange color behavior may reveal new chemistry never seen outside laboratories, and it might teach us how light behaves when it touches matter older than our solar story. There's a quiet magic to that, a reminder that color isn't just beauty, it's information. Through 3i Atlas, we're learning that even light can keep secrets, choosing when and how to reveal them. The idea sounds impossible. Stars so heavy they trap their own light but don't die. Physicists call them black hole stars, and JWST might have just glimpsed their ghosts at the edge of cosmic dawn. These titans could be the missing link between the first stars and the black holes that came after. They burn not by fusion, but by gravitational energy, collapsing inward while shining outward, a paradox that somehow works. If confirmed, it means the early universe was stranger and brighter than we imagined, full of suns that were half light, half shadow, and perhaps within those shadows the first elements of life were forged. It's eerie, almost poetic, that the universe's earliest lights were born from darkness itself. And maybe that's why the story matters, because it reminds us that beginnings and endings often wear the same face. In the centers of galaxies, chaos reigns, but JWST found order hiding there. Behind curtains of dust, it revealed nurseries of newborn stars orbiting around black holes, their light flickering like candles near a storm. It means galaxies aren't static giants. They're living systems that feed, breathe, and evolve. Even near destruction, creation continues. Webb's infrared eyes see that constant exchange, gas falling in, stars bursting out like a universal heartbeat. Some of these galactic hearts show patterns that mimic biological rhythms, pulsing bursts of radiation repeating every few hours. Coincidence, maybe. Or maybe the cosmos hums in cycles we're only beginning to hear. And when you look at those images, swirling clouds glowing around invisible cores, you realize something quietly profound. The universe doesn't hide its heart from us. It's been shining all along. We just needed the right eyes to see it. When astronomers first calculated the speed of 3I Atlas, they laughed softly, not out of disbelief, but awe. This comet is moving faster than any natural object we've ever studied up close, over 130,000 miles per hour, swift enough to travel from Earth to the Moon in just under 2 hours. But speed alone isn't what makes it remarkable. Its endurance. 3I Atlas has been traveling for millions, maybe billions of years, never slowing, never colliding, just gliding through the dark like a whisper that refuses to fade. Each mile it crosses is another page of history unread, another story passing silently beneath the stars. Scientists believe it was thrown from its home system after a gravitational event. Perhaps a planet-sized world tugged it too hard, flinging it outward forever. Now it visits us only once, a reminder that even lost things can still find their way into someone's sky. While the world stared at Webb's big headlines, one quiet discovery slipped by unnoticed, an ancient ring of galaxies, perfectly aligned like pearls in space. It shouldn't exist. Gravity isn't supposed to form patterns that neat. And yet there it is, glowing faintly 9 billion light-years away. Astronomers call it the Great Ring. Its symmetry suggests something deeper, a structure that hints at unseen forces shaping the universe's architecture. Maybe dark matter isn't as random as we thought. Maybe the cosmos has its own quiet geometry. That realization carries a strange comfort, that even the chaos of creation might hum to a rhythm too vast for us to hear. And the fact that this pattern went unnoticed for months reminds us that sometimes the universe reveals its secrets only to those who look gently, not loudly. Every comet carries a signature, a chemical fingerprint of its origin. 3I Atlas's signature, though, reads like a biography of an ancient sun. Its tail releases metals like iron and nickel, elements only born in supernovae. That means this comet was forged near a dying star that once exploded into brilliance. Those metals drifted for eons before cooling into ice, forming the solid body that now crosses our solar system. So when you see its faint glow, you're not looking at just rock or gas. You're seeing the recycled heart of a vanished star. And there's something tender in that idea, Wahed, that even stars, when they die, leave gifts behind. Perhaps 3I Atlas is a messenger of cosmic inheritance, proving that endings in the universe never truly end. They just change form and begin again far from home. With each observation, JWST paints a softer portrait of the cosmos, one that feels less mechanical and more alive. Recently, it detected carbon-based molecules in a galaxy so ancient we didn't expect them to exist yet. That means chemistry, and maybe life's precursors, began far earlier than we believed. These discoveries quietly rewrite our sense of time. If organic matter bloomed so soon after the Big Bang, then maybe the spark of life isn't rare. Maybe it's the universe's natural language, a quiet code written in starlight and patience. It makes you wonder, if the cosmos keeps planting the same seeds across galaxies, how many gardens of life might already be out there, waiting to be seen? JWST hasn't just shown us distant galaxies, it's shown us how alive the universe might truly be. Every week, astronomers refine their measurements, and 3i Atlas keeps breaking the math. Its acceleration changes slightly as it moves closer to the Sun, but not in the way radiation pressure predicts. It's like a ship catching a wind that shouldn't exist. Some scientists think hidden jets of gas are firing from beneath its crust. Others suspect electromagnetic interactions beyond our current models. Whatever the cause, the comet moves as if it knows where it's going. Steady, deliberate, graceful in its disobedience. There's a strange beauty in that. A reminder that even in a universe built from laws, exceptions always exist. And maybe 3i Atlas is one of those quiet rebels, proving that mystery, not certainty, is what keeps science alive. Most comets are predictable. Sunlight warms them, ice melts, tails form, they fade away. But 3i Atlas refuses to follow any script. It twists its own path, flickers without warning, and sometimes brightens when it should dim. It's like a traveler ignoring the map, guided by an instinct older than gravity itself. Astronomers have learned to expect surprises from it. Some nights, telescopes capture plumes of dust blooming in strange directions, sideways, even upward. No model fits perfectly, and that's the charm of it. The universe doesn't always explain itself. Sometimes it simply performs. Perhaps that's why 3i Atlas feels alive, not as a creature, but as an event that breathes mystery. Every time its orbit curves, it reminds us that not everything that moves must make sense. When galaxies collide, it isn't destruction, it's renewal. Through JWST's eyes, we can now see these cosmic embraces in their true color, fiery clouds birthing new stars amid the chaos. Two galaxies merge, their spiral arms twisting together like lovers in slow motion, each reshaping the other forever. Webb's infrared vision peers through the dust, revealing that collision isn't violent at all. It's creative. Stars spark where gas compresses, worlds may form from what once looked like ruin. There's a strange peace in that image, knowing the universe builds beauty from impact. Maybe that's its lesson to us too. Even when forces collide, new light can emerge from the mess. When researchers pointed radio telescopes at 3i Atlas, they picked up a faint hum. Not sound, but electromagnetic whispers. It wasn't noise, it was structured, rhythmic, like the slow pulse of a cosmic heartbeat. The radiation pattern puzzled scientists. It didn't match solar wind interference or known comet emissions. Instead, it suggested oscillations within the comet's magnetic field, something never recorded before in an interstellar object. This could mean 3i Atlas carries minerals that interact unusually with sunlight, converting energy into radio waves. Or perhaps it's simply teaching us that interstellar materials behave differently when crossing our familiar space. Whatever the truth, those signals are tiny gifts. Proof that even silence hums when you learn how to listen. Dark matter has always been the universe's great ghost, invisible, untouchable, yet everywhere. We can't see it, but JWST lets us feel its presence through the bending of light. By observing distant galaxies distorted like reflections in rippled water, Webb maps the unseen scaffolding of creation. It reveals that dark matter isn't scattered randomly. It forms filaments and nodes like a vast cosmic web holding galaxies together. The image is haunting. Billions of suns dancing to the pull of something we'll never touch. And yet there's comfort in that too. Even in the dark, there's structure. Even in the invisible, there's meaning. Perhaps dark matter is the universe's reminder that not all truths are meant to be seen, only sensed. When astronomers realized 3I Atlas came from another solar system, a quiet thought emerged. What if it carried dust from alien worlds? Tiny grains trapped within it might once have been part of planets circling distant suns. If true, that means this comet is a messenger, a cosmic postcard from another neighborhood in the galaxy. By studying its chemical traces, we could glimpse what other solar systems are made of, and maybe what life could be built from there. It's humbling that something so small could bridge light years and spark such big questions. 3I Atlas may not be alive, but it carries the memory of places that once were. And that's enough to remind us. Space isn't empty. It's full of stories just waiting for a listener. It's strange to think that most of what fills the universe isn't stars or planets, but dust. Tiny drifting grains of carbon and silicate, floating between galaxies like silent messengers. Yet, these little particles are storytellers. They hold the fingerprints of dead stars, the breath of nebulae, the ashes of creation. JWST's instruments can read their signatures, mapping what kind of light they absorb and what kind they reflect. From that, astronomers reconstruct entire histories: when the star that made the dust died, how far it traveled, and where it might settle next. Sometimes dust from one star becomes part of another, a quiet reincarnation written in atoms. And maybe that's the most poetic truth of all. Everything you touch, everything you are, once floated freely in that cosmic dust, waiting to become something again. Space isn't empty. It's laced with unseen filaments. Cosmic bridges made of dark matter and thin plasma, connecting galaxies like threads in an infinite web. For years we thought galaxies floated alone, but JWST revealed faint glows where gravity knits them together, light bending through invisible strings. These filaments act as highways for matter, guiding it from the void into the hearts of new stars. They pulse slowly, carrying energy like veins in a living organism, suggesting the universe isn't static, but alive in its own vast rhythm. If you could zoom out far enough, you'd see it, the entire cosmos shimmering as one connected structure. It's humbling, realizing that nothing exists alone, not even galaxies. Everything is quietly holding hands across the dark. Imagine a beam of light traveling straight for billions of years, then curving softly for no visible reason. That's gravitational lensing, one of the most beautiful tricks of physics. Mass, even invisible mass, bends the very fabric of space, and light simply follows that curve, like water around a stone. JWST has captured breathtaking examples: galaxies mirrored, stretched, duplicated into delicate arcs of light. To us, they look like halos, as if the universe itself wears its mysteries like jewelry. But behind that beauty lies precision. By studying these bends, scientists can weigh entire clusters, map dark matter, even peer behind cosmic curtains into galaxies otherwise hidden. It's as if the universe found a way to let us see around corners, gifting us mirrors made of gravity itself. Every star sings. not in sound but in vibration. Its surface ripples from pressure waves deep inside, sending out frequencies that can be measured, a celestial heartbeat across space. Astronomers call it asteroseismology, and JWST can now record these delicate rhythms in detail never possible before. Each frequency tells a story about the star's age, density, and even mood. You could say stars keep diaries, and we've only just learned to read their handwriting. When you listen to their oscillations turned into sound, it's haunting, soft, almost human. And maybe that's no coincidence. After all, the same physics that makes stars pulse also makes our hearts beat. The cosmos hums, and we somehow hum along. We often imagine the universe like a bubble, something with an edge. But the truth is both simpler and stranger. It doesn't have one. There's no wall, no border, just endless curvature, space folding back on itself like a vast cosmic sphere. JWST has looked so far that it nearly touches the beginning, and yet there's always more beyond reach. Light takes time, so when we look outward, we're looking backward, into our own past. That means the edge of the universe isn't a place, it's a time. Somewhere out there, light still traveling toward us holds the next page of the story. And maybe we'll never see it all. But that's okay, because wonder doesn't come from knowing where the edge is. It comes from realizing the story never really ends. The universe isn't just filled with moving galaxies. Space itself is expanding. That means the galaxies aren't flying apart through space. Rather, the fabric of space is stretching, carrying them away like dots on an inflating balloon. It's a concept that sounds simple until you sit with it, because it means even light itself gets stretched as it travels, its color slowly turning red with distance. JWST measures this redshift with unmatched precision, revealing that the farther something is, the faster it recedes. And yet, that expansion isn't uniform. Some areas swell faster than others, as if the cosmos breathes in uneven rhythms. We don't yet know why. Maybe dark energy is accelerating it, or maybe there's something deeper, an invisible pattern behind expansion itself. Either way, it's quietly astonishing to think that space isn't static. It's alive, moving, and still growing as you listen to these words. Between stars lies a silence so complete it could swallow time. No air, no wind, just stray atoms drifting miles apart, glowing faintly when cosmic rays strike them. It's a place colder than imagination, where light takes centuries to cross a single thought's worth of distance. But this stillness isn't empty. It's full of fields, magnetic, gravitational, quantum. Tiny ripples move through it, unseen but real, shaping how galaxies breathe and how matter clumps together. Some scientists call this the interstellar medium, but that phrase doesn't capture its poetry. It's more like the pause between cosmic heartbeats, the waiting space where creation gathers its breath before forming a new star. And if you could float there, weightless and quiet, you might realize something profound. Even in the universe's silence, there's motion. Even in the dark, there's music too soft for ears to hear. Gravity doesn't just pull, it bends time itself. Near massive bodies like stars or black holes, clocks slow down, seconds stretch into hours, hours into eternity. JWST can't see time directly, but it captures the signatures of its bending, light warped, spectra stretched, moments elongated beyond recognition. To us that's physics, but it's also poetry. Imagine a photon leaving the surface of a star, fighting gravity's grip for billions of years, aging more slowly than everything else in the cosmos. When it finally reaches us, it carries two stories, one of distance, one of time itself, losing its usual meaning. And maybe that's the universe's quiet joke, that nothing truly stands still or passes evenly. We live inside time, but time too lives inside gravity's long, unhurried breath. At first glance, space looks random. Stars scattered like seeds across a dark field. But zoom out far enough, and a pattern appears: filaments, clusters, voids, a cosmic lattice stretching beyond imagination. It's as if creation followed invisible geometry, forming balance out of what looks like chaos. Mathematicians find fractal structures in this vastness, repeating patterns from atoms to galaxies. The same logic that shapes snowflakes may govern the arrangement of superclusters. That connection makes everything feel strangely intimate, like the universe is painting with one steady hand, just on different scales. We often think of chaos as disorder, but maybe it's simply order too complex to recognize. And in that mystery lies comfort, that even the wildest patterns are part of something deeply intentional, humming softly beneath all existence. There's a common thought that someday everything will stop, that stars will die, galaxies fade, and heat will dissolve into silence. But physics hints at something gentler. The universe doesn't stop. It only changes its rhythm. Even as expansion cools the cosmos, new structures emerge, quantum ripples, vacuum energy, perhaps even new universes budding quietly from this one. Stillness, it seems, isn't an ending, it's a transformation. Every proton, every wave of light participates in this eternal dance. We are not separate from it, we are it, tiny flickers of awareness inside a vast, breathing organism of time and space. And maybe that's the true secret JWST helps us see, that the universe isn't a thing to study, but a story we're already inside. And it's still being written softly, endlessly, in the dark between stars. Even in the darkest parts of space, there is light. It's faint, a soft microwave whisper known as the cosmic background radiation. This light is the echo of the universe's first breath, still traveling, still glowing, long after the fire faded. JWST doesn't see this ancient glow directly, but everything it observes swims in its quiet sea. It's the backdrop of all creation, the oldest thing we can ever touch with our instruments. That glow isn't gone, it's just stretched, cooled, softened by time. It reminds us that warmth lingers. Even after the brightest explosions, even after the loudest beginnings. Out beyond Jupiter and Saturn, where sunlight barely reaches, lie worlds covered in ice. But under that ice, there may be oceans, Europa, Enceladus, Titan, all whisper of liquid water sealed beneath frozen skin. JWST can detect traces of vapor plumes, the chemical breath of these hidden seas. Some even contain hints of methane carbon compounds, the building blocks of life itself. It's haunting to think, entire alien oceans moving in eternal night, never touched by sun or air. And yet maybe warmth isn't only born of starlight, maybe it's born from the heart, from friction, from persistence. Somewhere out there, waves might be breaking softly under ice unseen, proof that even in coldness, life keeps its quiet rhythm. Most stars fade or explode, but some, the so-called zombie stars, refuse both fates. They collapse halfway, then reignite, burning faintly with borrowed fuel from nearby companions. Astronomers call them white dwarfs with accretion disks, but their story sounds more like defiance than science. JWST has found several such stars flickering weakly, yet refusing to go dark. Their gravity pulls matter from neighbors, feeding just enough to glow again. Not bright, but stubbornly alive. There's poetry in that survival, not strength, but persistence. Even stars, it seems, would rather dim than disappear. And maybe that's the universe's most honest reflection of us. Fragile, fading, yet unwilling to stop shining. We think of nothing as empty, but in physics, emptiness has structure. The vacuum of space teems with virtual particles popping in and out of existence, like sparks in invisible wind. JWST's instruments can't see them, but their fingerprints ripple through light, altering what reaches our eyes. This restless void gives birth to forces, energy, even gravity itself. It's the quietest chaos imaginable, the foundation of all being, buzzing silently with potential. To call it nothing almost feels unfair. Maybe it's better to call it resting everything. Because even when there's nothing left to see, the universe still hums softly beneath the silence. Light doesn't just illuminate, it remembers. Every beam carries the fingerprint of where it came from, the temperature, the motion, the elements that burned to create it. When that light reaches us, billions of years later, it's still whispering its origin story. JWST reads those whispers like an archaeologist, turning color into chemistry, brightness into history. From a single spectrum, scientists can tell if a galaxy is birthing stars or watching them die. It's astonishing that information can survive the collapse of suns and the death of time itself. Every photon is a messenger, a traveler, a tiny capsule of memory. And when it lands in our instruments, the universe, in some small way, finally remembers itself. Our planet isn't just floating in space or it's balancing. Every gust of wind, every current of water, every heartbeat depends on invisible forces staying in perfect rhythm. Gravity pulls us inward, sunlight pushes life outward, and somehow they agree to dance instead of fight. Astronomers call this fine-tuning, the delicate harmony of physics that makes existence possible. The same constants that shape galaxies also shape your breath. Change them even slightly, and the stars wouldn't burn, water wouldn't flow, and we wouldn't be here to wonder. So, when you look up at the night sky, remember, the entire universe had to cooperate for you to exist. That thought alone makes life feel like the rarest, most intentional accident ever made. Planets don't speak with words, they communicate through gravity. Their orbits nudge, pull, and sway each other in slow, invisible dialogue. Sometimes two worlds fall into rhythm, their revolutions syncing up like dancers who never met yet share the same song. These gravitational whispers ripple outward, forming resonances that keep entire solar systems stable. JWST has begun observing how these patterns extend to exoplanets light years away, where unseen worlds tug at the stars they circle. It's strange to imagine a whole language built from motion, silence, and time. And maybe somewhere in that cosmic rhythm, the universe keeps its oldest promise. That connection never needs words, only gravity and patience. Some physicists now wonder, could the universe itself process information like a mind? Every particle carries data. Every interaction changes it. Over cosmic timescales, this web of computation could behave almost like thought. Not conscious, perhaps, but aware, in structure. It's a theory called pan-computationalism, and it challenges how we define intelligence. If true, then black holes, galaxies, even comets are part of a giant network, an endless system learning itself through motion. Maybe consciousness isn't confined to brains, but built into the fabric of reality. Maybe when we think about the universe, it's thinking back, softly, curiously, through us. JWST feels new, yet astronomers already dream of what comes next. Projects like LUVOIR and Origin Space Telescope aim to see even deeper, to watch the first molecules form, to catch planets in the act of breathing. These future telescopes will use mirrors wider than houses and detectors so sensitive they could spot the heat of a single candle across the moon. It's science fiction slowly becoming fact, and the thought of it is soothing this day that curiosity doesn't stop. Every generation builds a window for the next one to look farther. Someday, a child not yet born will gaze through those lenses and see something we can't even imagine yet, and whisper, "So that's where we come from." After all, the telescopes, theories, and stars, it always circles back to this: you are made of the same atoms that burned in the first generation of suns. The calcium in your bones, the iron in your blood, the oxygen in your breath, all born from exploding stars. You don't just live in the universe lives through you. Every thought you have, every heartbeat, is part of its ongoing experiment in awareness. When you look up at the night sky, you aren't gazing at something distant, you're remembering your origin story. You are quite literally the cosmos finding a way to feel wonder for itself. There's a kind of quiet in space that isn't just the absence of sound, it's the pause between stories. Radio telescopes sweep the skies every night, catching hums, pulses, and bursts. But between those signals lies something stranger. Silence so deep it feels alive. This isn't emptiness, it's potential. The void between messages is as important as the messages themselves because it's there that the unknown hides, waiting for someone patient enough to listen. Scientists sometimes call it the cosmic background of nothing, but that nothing is filled with data. It's the quiet that lets us detect the faintest heartbeat of a distant pulsar or the whisper of a dying quasar. Without silence, there would be no discovery, only noise. That thought alone reshapes how we see space, not as a void, but as a canvas stretched taut with anticipation. Every telescope, from Earth to orbit, listens to that silence differently. Some hear the soft afterglow of the Big Bang, others wait for unnatural patterns that might reveal intelligence. And though we haven't yet found a definitive hello from beyond, the waiting itself becomes meaningful. A global meditation beneath the stars. Perhaps that's what the universe teaches most through silence, patience. In those long, quiet gaps, it invites us to slow down, breathe, and realize that discovery isn't only about finding, it's also about being still enough to notice what's already speaking without words. It sounds backwards, doesn't it? That something which swallows everything could also create. But black holes do. In the heart of most galaxies lies a supermassive one, millions of times heavier than the Sun, turning silently like a heart driving the system's rhythm. As matter spirals inward, energy bursts outward, jets of radiation shooting across thousands of light years. These jets regulate star formation. Too much energy and stars can't form. Too little and gas collapses too fast. So black holes act like cosmic thermostats, balancing creation and destruction in perfect measure. JWST can now see this dance up close, revealing that these dark engines shape galaxies the way wind shapes dunes. It's mesmerizing to think of darkness as an architect. We once saw black holes as monsters, but they're gardeners too, pruning and guiding the galaxy's growth. Every light in the night sky owes something to their unseen influence. And maybe there's a quiet metaphor there, that even the heaviest, darkest forces in life can create balance if seen from far enough away. That destruction and creation are never opposites, just two sides of the same eternal breath of the cosmos. We dream of Mars, of exoplanets, of other suns. But maybe life hides closer to moons we've ignored for decades. Europa, Enceladus, Ganymede, icy worlds orbiting giants glowing faintly in reflected light. JWST recently captured chemical traces around them that hint at organic molecules, maybe even vents, like Earth's deep-sea ridges. Think about that. Oceans beneath ice, thicker than mountains, warmed not by sunlight but by gravitational friction. The very pull of Jupiter or Saturn could be stirring warmth into liquid seas, oceans where darkness might glow with alien life. If microbes exist there, they might never have seen a star. They'd live in blackness, feeding on chemical energy, adapting in silence for billions of years, unaware that light even exists. And somehow that's comforting. Life doesn't always need the same conditions as ours. It simply needs persistence, the will to exist where logic says it shouldn't. So while telescopes look outward, perhaps the greatest discovery will come from beneath the ice of our own backyard. Proof that life doesn't ask permission to bloom. It just does. Why are galaxies spiraled, shells curved, flowers symmetrical? It's not coincidence, it's math. The Fibonacci sequence, the golden ratio, fractal geometry. These aren't human inventions. They're the language nature already speaks. JWST's deep field images show spiral galaxies whose arms follow perfect logarithmic curves, the same ratio that appears in pine cones, hurricanes, and seashells. It's as though creation itself has a favorite rhythm, repeating across scales so vast they defy comprehension. Even starlight follows patterns, intensity and spacing forming harmonies like chords in a song. Mathematicians can predict where beauty will appear, and still, every discovery feels like surprise. Because numbers don't just describe symmetry, they become it. And maybe that's the secret. Beauty isn't decoration, it's structure. It's the signature of coherence, the universe's way of saying everything fits, even when you can't yet see how. One day, a telescope far from Earth will look back, and will be the pale blue dot shimmering faintly in a sunbeam. That image will remind us of how small, yet how precious we are. Every war, every love story, every song, all contained in a single pixel. Carl Sagan once said that humility comes from perspective. JWST's successors will deepen that humility even further. When we see our own world through cosmic eyes, it doesn't make us feel insignificant. It makes us feel connected. Light from Earth already travels outward, carrying our signals, our laughter, our mistakes. Perhaps one day it will reach another telescope, another consciousness, somewhere who will see us as we see them. Tiny, fragile, luminous. In that moment, humanity might finally understand that space isn't out there. It's here too, seized within us, breathing, remembering, because we were never observers of the universe. We were always part of its dream. Every second, the universe flickers, not just with light, but with probability. At the smallest scale, space itself vibrates with quantum fluctuations, particles appearing and disappearing faster than thought. Physicists call it the quantum foam, the restless breath beneath reality's surface. If you could somehow shrink yourself small enough to see it, you wouldn't find stillness. Why, you'd find an ocean of shimmering possibilities, forming and dissolving in infinite rhythm. JWST can't observe the quantum realm directly, but everything it sees is built upon it. Every photon, every star, every planet began as a vibration in that invisible sea. This means that the foundation of the cosmos isn't solid, it's creative. Reality doesn't sit still, it writes itself over and over, trillions of times per second. We live in something that doesn't just exist, it happens. And that's where the poetry begins. The same quantum rules that shape stars also shape your heartbeat, your thoughts, your choices. You are not separate from that flicker. You are it, arranged into consciousness. To exist, then, is to ripple with the same mystery that breathes galaxies into being. So perhaps the universe doesn't just expand outward, it expands inward through awareness. In every moment of silence, the quantum world hums beneath your skin, whispering the same thing it's told the stars. You were never static. You were always becoming. Galaxies age too. Slowly, quietly, beautifully. They begin as clouds of hydrogen, young and bright, swirling with fire. Over billions of years, that fire cools, starbirth slows, and dust settles into calm spirals of memory. Yet even in their twilight, galaxies keep creating. Smaller stars, gentler light, the cosmic version of a sunset. JWST has shown us ancient galaxies, still glowing softly, even when logic says they should have gone dark. Some continue forming stars using leftover gas, recycling what remains like old souls refusing to stop singing. Their light carries a warmth, not just brightness, but endurance. In these aging galaxies, astronomers see the echo of balance. They no longer rush. They've found rhythm, slow, steady, wise. Every spiral arm becomes like a wrinkle of time, holding everything they've been through. And maybe that's what aging gracefully means. Not fading, but transforming into a softer kind of brilliance. Galaxies don't die. They remember. And perhaps when the universe looks back at itself, it'll see that beauty has always belonged to things that learn to let go. One day, time as we know it may stop behaving like time. Physicists say the expansion of the universe could stretch space so far that clocks lose their meaning. Galaxies will drift out of sight, stars will fade into black dwarfs, even atoms might fall silent. But that won't be the end, just a change in tempo. Some theories say quantum fluctuations will spark again, igniting new universes like seeds dropped from the husk of the old one. In this view, time never ends. It loops, resets, dreams itself into existence once more. JWST's glimpses of early galaxies already suggest this pattern, beginnings wrapped in endings, cycles hidden in chaos. If the universe began from nothing, perhaps nothing is simply what it returns to before breathing again. Like a heartbeat pausing, only to start anew. It's humbling to realize that time might be circular, not linear. That every sunset could be a prelude, not a farewell. And that maybe every soul, like every star, is part of a story that never truly stops. And not all light reaches us. Some gets trapped in dust clouds, some swallowed by black holes, some scattered into directions no eye will ever see. Astronomers call it cosmic background extinction, the fading of light that once existed but can no longer be found. JWST, however, can sense some of it. Faint echoes buried deep in infrared wavelengths. That means even forgotten stars still speak, long after they've vanished from visible sight. Their photons wander space for eternity, like memories too precious to erase. It makes you wonder, oh dear, how much light have we missed? How many suns have burned beautifully in total silence, with no one to witness them? And isn't that still meaningful? Because in the universe, beauty doesn't depend on being seen. It simply is. Every unseen beam reminds us that creation doesn't perform for an audience. It creates because it must. The same way your heart beats without asking who's listening. Somewhere out there, light from forgotten stars still travels toward us, late but faithful. Proof that nothing luminous is ever truly lost. There's a moment when looking up at the stars where you stop asking questions and just feel. That's when the boundary between the observer and the observed disappears. You realize that you're not looking at the universe, you're looking from within it. Every thought, every heartbeat, every wonder is the cosmos thinking about itself. The atoms that form your eyes were once inside a star, The light that fills those eyes is the same light that taught galaxies how to shine. It's not a metaphor, it's literal. You are the universe, conscious for a brief, extraordinary while. Maybe that's why curiosity feels sacred, because when we study the cosmos, it's not exploration, it's remembrance. It's the great whole remembering its own spark, one human breath at a time. And someday, long after the stars have dimmed, maybe that awareness will spark again, somewhere, somehow, because creation doesn't stop at physics, it extends into wonder, and wonder perhaps is the universe's favorite way of keeping itself alive.